right, so we've drawn our car, and that's located up here in the top left, this general region. And we've got our velocity, we've got our mass at 1,000 kilograms, we've got our initial speed at 36 meters per second, the final speed was 20 meters per second, the force of friction acting on the car is 7,000 newtons, and we want to know how far this thing is going to go. We're going to use the work energy theorem for this, and the work energy theorem is the total or net work on the car is going to equal the change in kinetic energy of the car. Well, what force out of the ones that are up on this car are doing the work? And that would be the force of friction, because that's the one that's trying to slow it down. So the work done by friction is the force of friction times the distance that friction operates. Now, you might say, hey, how come we don't have the distance? Do we not know that when I thought it said that it was 50 meters until the cop car? We're not using the 50 meters because it's not saying that you do this in 50 meters. You don't slow down in 50 meters. It wants to know, do you slow down before you get to the cop, before the 50 meters, or do you go beyond? So our work is force of friction times d. I'm not sure what that is, but that's what we're trying to find. And kinetic energy, the change in kinetic energy, is the final kinetic energy minus the initial kinetic energy. So when I expand what the kinetic energies are, kinetic energy final is 1/2 mass times final speed squared. And the initial kinetic energy is 1/2 m initial speed squared. And we're trying to solve for d. So what I'm going to be able to do is divide the force of friction over. Actually, I made one small mistake, that the force of friction is going in the opposite direction of the way that we're going. So if to the right is positive, the work done by friction is to the left. So that should be a negative there. So now what I'm going to do is I'm going to be able to divide by my force of friction. So I have on my right side 1/2 mass times final speed squared minus 1/2 mass initial speed squared, all divided by that negative force of friction. And now I can plug in my numbers and solve. So I have 1/2 times 1,000 kilograms times the final speed, which was 20 squared, minus 1/2 times the 1,000 kilograms times the initial speed, which was 36 meters per second, also squared. And I'm going to divide all that by that negative 7,000 newtons that friction is. And what we find out is that how long does it take me to get down to the speed limit? It takes me 64 meters to get down to the speed limit, which unfortunately is 14 meters past the cop.